Hello everyone, today we are going to discuss the low-level design of a restaurant food ordering and rating system. You may have used apps like DoorDash, Swiggy, Zomato, Uber Eats, and that's what we are going to discuss today. This is a fairly common low-level design interview question, whether you are appearing for ST1, ST2, or even senior software engineer interviews, and it can be asked in several different ways. For example, you may be asked to do the low-level design of product ordering and rating feature for an e-commerce website like Amazon, eBay or Walmart. We are going to do 4 things today. First, we will discuss the problem statement from CodeZym and see what are the requirements. Then we are going to break the overall solution into different classes and also discuss the various design patterns which we will be using to solve this. Here, we will be using observer pattern and a slight variation of a strategy design pattern. After that, we are going to write the code for our solution in Java. Once the code is written, we will test it on CodeZym. CodeZym provides us with a multi-threaded environment. Here, we will be able to run our code against multiple test cases. And each test case will use thousands of threads, lightweight threads actually, to verify the correctness of our solution code. Also, you should copy default code from CodeZym editor to your local IDE like IntelliJ, Eclipse or NetBeans. Complete your solution in it and then finally paste back the completed code for running tests. You can click the YouTube video link on top right of this video screen which shows how it's done. So let's go ahead. In any food ordering app, there are basically 3 steps. First of all, user sees the restaurants and orders food items from a given restaurant. After some time, the food is delivered by a delivery person, and finally user rates the orders based on how good the food was. For this question, we are interested in only 2 steps. The first one, that is ordering food, and the second one, that is rating orders. Here is the problem statement. As you can see, there are restaurants and each restaurant sells a set of food items. Users can order food from restaurants and rate those orders. You can go through the complete problem statement on your own using this CodeZym link. This is question number 5 from CodeZym. I will just discuss the methods that we need to implement. First method that we need to implement is add food item. Each food item will have a unique ID, price and a name. Also, for simplicity, we have assumed that price of a food item will be same across restaurants. That is, Veg Burger will cost Rs 240 whether it is being sold in restaurant 1 or restaurant 4 or any other restaurant. In interview, you need to clarify these things from your interviewer. That is, whether the price of food item will be same across restaurants or will it be different. Next, we need to implement add restaurant. Each restaurant will have a unique ID, a list of food item that it is going to sell, a name and an address. For example, this is restaurant 1 and it is selling food 1, food 6, 8, 10, 11, 14 and 16. Its name is Pind Baluchi and it's in Inner Circle, New Delhi. Next, we need to implement order food. For now, let's assume that only a single food item is purchased in one order. You can see the example here. Customers can rate their order. When you are giving rating to an order, example giving 4 stars to an order of food 1, which is Veg Burger from restaurant 1, then it means that you are assigning 4 stars to both the Veg Burger from restaurant 1 as well as 4 stars to the overall restaurant 1's rating. Upcoming methods are going to show us why we need the rating update to affect 2 places. Users should be able to fetch best restaurants for a particular food item. For example, if you are looking to order Veg Burger, then you will naturally want to order it from the restaurants where Veg Burger has the highest average rating. This method fetches a list of top 20 restaurants and those restaurants are sorted in descending order of their average rating of that particular food item. In our case, it is food 1 Veg Burger. And then they are sorted based on the restaurant IDs lexicographically. For example, if Veg Burger is rated 4.3 in restaurant 4 and 4.6 in restaurant 6, then we will return restaurant 6 and then we will return restaurant 4. Users should be able to fetch top rated restaurants. Here we are talking about restaurants' overall rating and not the food items rating. This method returns top 20 most rated restaurant IDs sorted in descending order of their ratings. And if 2 restaurants have the same rating, then they will be ordered lexicographically by their restaurant ID. For example, restaurant 2 has average rating of 4.6, restaurant 3 is rated 4.2, restaurant 5 is rated 4.4, and restaurant 6 is rated 4.6. Then the final solution will be, answer will be restaurant 2, restaurant 6, restaurant 5 and restaurant 3. Even though restaurant 2 and restaurant 6 had both the same average rating of 4.6, since the string restaurant 2 lexicographically comes before the string restaurant 6, so in the answer also the restaurant 2 appears before restaurant 6. Your code will be tested in a multi-threaded environment, so use thread-safe data structures and handle synchronization properly. Also, no conflicting calls will be made. For example, rate order is a write operation on ratings, and get top rated restaurants or get top rated restaurants by food are read operations. So method called to rate order will never be done concurrently with get top rated restaurants or get top restaurants by food for a given food item in a given order ID. This is done to keep the system state consistent and also test accurately in a multi-threaded environment. Ratings for unrated restaurants or food items should be considered 0. Unrated means rate order has not been called for any order from that restaurant or for that food item. The second thing is ratings will range from 1, 2, 3 or 5, 4 or 5 stars, where 1 is the worst and 5 is the best rating. The next point is average ratings are rounded down to 1 decimal point. So 4.05 or 4.08, 4.11, 4.12 or 4.14 all become 4.1. Again 4.15, 4.19, 4.22 all these become 4.2. So anything before 0.05 is truncated and anything after 0.05 is moved on to the next single decimal point. Let's discuss the solution code now and how we will break the overall problem statement into different classes. In any low-level design question, the simplest way to approach is to figure out all the entity classes and their corresponding manager classes. And then we go for design patterns. Here, class solution has a method add food item. This suggests that there is going to be an entity food item and that entity food item will have a corresponding manager class food manager. For now, we only decide the entities and corresponding manager classes and later we will dive into details. Next, we have a method add restaurant. This means there is going to be an entity class restaurant and corresponding manager restaurant manager class for managing all the collection of restaurant objects. Next, there are methods order food and rate order. So there is going to be an entity class order and there is going to be a corresponding orders manager. We also have methods get top restaurants by food and get top rated restaurants. These are sort of the search restaurants method. Now let's not worry about these methods for now. Just assume that there is a class restaurant search manager which takes care of the implementation of these two methods. For now, let's just discuss our entity classes and then we will go for their corresponding managers. We have class food item and a corresponding class food manager. We also have class restaurant manager and finally we have class orders and class orders manager. Also notice that we haven't created an entity class for restaurant and have kept all the data in class restaurant manager. Generally in LLD interviews, especially where machine coding is involved, you will always find yourself short of time. So it's better to avoid writing code which is not required. Let's discuss these classes first and then we finally discuss the restaurant search manager for implementing the search functionality. Our first entity class is food item. We have the constructor which is initialized by all three parameters food item ID, food item name and price. And then we have getters for all these parameters. The class food manager stores the collection of food item objects. It has two methods, the add food item and get food item. It stores the food item objects in a concurrent hash map of food item ID versus food item object. We didn't use a simple hash map here because in a multi-threaded environment, it can give concurrent update exception or data may get corrupted during write operations. Restaurant manager has methods to add restaurant, get all restaurants which sell a particular food item, and get the list of all restaurants which are in our system. It keeps the list of all restaurants in a concurrent linked DQ, which is a thread safe linked list. Now, map is actually a map of or a concurrent hash map of food item ID versus list of restaurant IDs of restaurants which sell that particular food item. Add restaurant method adds the restaurant ID to the list of all restaurants, and then it goes through all the food item IDs that the restaurant is planning to sell. It fetches the corresponding list of restaurant IDs which sell that particular food item, and it adds the current restaurant ID to that list. Here I have used array list with synchronized. I could have used again a concurrent linked DQ like I used for storing all restaurants, but I wanted to show you how to achieve thread safety using array list and a synchronized keyword. Although using array list with synchronized keyword is slightly less efficient than using a concurrent linked DQ. Next is get all restaurants by food item ID. So basically it fetches the list of restaurant IDs which sell this particular food item ID and returns it. We have already prepared this list in the add restaurant method as we saw. And next is get all restaurants, which actually just return this all restaurant data structure, and it converts this concurrent linked DQ to a collection of string so that it can be easily iterated. It's generally a good practice to convert your return types or returning objects into unmodifiable or final because it helps mitigate errors, especially when you are working in a multi-threaded environment. Our next entity class is order. Its constructor takes order ID, restaurant ID, food item ID, and rating. Then we have all the getters for all its parameters, and it also has a set rating method which will be used in the add rating method from class solution. Our class orders manager will manage the collection of order objects. It keeps all the order objects in order a concurrent hash map of order ID versus order. Let's ignore this observers list for now. We will visit it when we are discussing the search functionality. It has two methods, order food and rate order. Order food simply adds the newly created order object in this map, and then rate order, it actually sets the rating. We just saw the set rating method in the class order. For now, let's ignore the notify all. Now let's go through the methods in the class solution, which is actually the default class that is provided by the CodeZym editor, and it will be the driver class. The first init method is used to initialize all the managers, food manager, restaurant manager, and orders manager. Let's ignore restaurant search manager for now. Helper object will be used for logging, and you should use this instead of system.out.println, else your logs will not be visible. Now, since we already divided our whole functionalities into different classes, so from the methods in class solution, only the corresponding methods from manager classes are called. For example, there is food manager.add food item, restaurant manager.add restaurant, orders manager.order food, and finally orders manager.rate order. Next, let us discuss how to solve the search functionality. We have two methods, get top restaurants by food and get top rated restaurants. The first one, get top restaurants by food, fetches list of restaurant IDs for average rating for a given food item, while the other method fetches the top restaurants based on their overall rating. Since the return type of both these methods are same, which is a list of restaurant IDs, that is a string, so it suggests the usage of a strategy pattern. But since input for both these methods are different, so we'll actually only be using concept from strategy pattern, and both these methods are implemented in the restaurant search manager class. Let us start with restaurant search manager. It has two classes, class most rated restaurants and class most rated restaurants by food for the corresponding search functionalities. Now, both these classes need to be notified whenever an order is assigned a rating. So, here we need to use an observer design pattern. An observer pattern has a subject which sends changes to the list of observers. This brings loose coupling between the data which is getting changed, in our case rating for the order, and the classes which show different views of that data. In our case, it is the most rated restaurants and most rated restaurants by food, which actually show top rated restaurants based on their overall rating and also based on the rating for a given food item. Class most rated restaurants and most rated restaurants by food are observers, Both these classes will implement the rate order observer interface and corresponding update method. This method will be called by our subject every time an order is rated. Class orders manager has the method to rate orders, so it is the ideal candidate for being our subject. Class orders manager will implement the interface rate order subject and the corresponding methods to add an observer and notify all observers when an order is rated. That is called update method on each observer. If you want to know more about observer pattern, then HeadFirst has a very good design patterns book, and also you can use websites like ooddesign.com or watch tons of videos on YouTube. Let's start with our subject. Class orders manager implements the rate order subject interface. It keeps the list of observers in this array list observers. Inside the rate order method, it calls notify all, which calls the update method on each observer to notify that the rating for a particular order has been changed. It just calls them with the orders object. Benefit of using observer pattern is of extensibility. Let's say tomorrow we need a new view like fetch restaurants with the highest number of 5-star ratings for a particular food item. Then that class will only have to implement the rate order observer interface, and then it will register as an observer using the add observer methods, and it will be getting all the rating changes, and it won't have to change any code in the class orders manager itself. So future code additions have become easier. Coming back to our class restaurant search manager, it initializes both most rated restaurants and most rated restaurants by food in its constructor, and then it adds both of them as an observer to the rate order subject, which we know is class orders manager. Here inside class solution, you can see how the restaurant search manager object is initialized with orders manager as the rate order subject and restaurant manager. Let's go through the first search method, that is get restaurants by food. This method first fetches the list of top restaurants for a particular food item. If the list already has 20 items or more, it returns. Here n is 20. If not, it fetches list of all restaurants including unrated restaurants which sell that particular food item using the restaurant manager instance. And then the method build top restaurants list is called to add unrated restaurants to already fetched list from most restaurants by food. It means this list. Both these lists are merged. The method build top restaurants list adds restaurant IDs with rating 0 to the existing list of top restaurant IDs. That is the rated. These all are rated restaurants. If you remember our sorting strategy, it states that the restaurant with same rating will be sorted lexicographically. That is strings in dictionary order according to their restaurant IDs. So this method first of all sorts all the restaurant IDs which we have. Then it goes through each item in the all list, and if that restaurant ID is not already added to this added list, that is existing rated restaurant IDs, then it adds it. And if the size becomes greater than equal to n, that is 20 in our case, then we return. Coming back to the other search method in restaurant search manager class, similar code is there. First of all, the list of top rated restaurants is fetched using the most rated restaurant instance, and if the list size is greater than n, we return it. Else what we do is we fetch the list of all restaurants IDs in our system and merge it with the existing list of rated restaurants. That is this list using the build top restaurants list like we did in the other method. Before discussing the classes which implement search algorithms, first let's discuss the class rating and class sorted set with lock. These two classes hold the actual logic which is used by both these algorithm classes. Class rating keeps the overall rating for a restaurant. It has two parameters, sum, which is the sum of all ratings, and the parameter count, which is the number of orders that has been rated till now. Now its method get average rating rounds down the overall rating to a single decimal point. Let's see how this works. Let's suppose the value in this line for rating is 4.15. So adding 0.05 makes it 4.20. Multiplying it by 10 makes it 42.0, and converting it to an integer makes it 42. And then finally we divide it by 10.0 to convert it to 4.2. What if the value of rating in this line was 4.14? So Adding 0.05 made it 4.19, multiplying it by 10 made it 41.9, and then converting it to an integer made it 41, and finally dividing it by 10.0 made it 4.1. So this is how rounding the rating to its average rating to a single decimal point works. The next method is add, which adds the customer rating to sum and increments the count by 1. So let's suppose earlier sum was 36 and count was 9. A new customer comes and they rate the order 5. So the new sum becomes 36 plus 5, that is 41, and the new count becomes 9 plus 1, that is 10. So the new rating is 41 by 10, that is 4.1, while earlier it was 36 by 9, that is 4.0. So this is how both these methods work. Class sorted set with lock is a thread-safe class, and it uses a slightly different approach to maintain a list of restaurant IDs sorted by their rating. And it also allows efficient update of overall average rating of list of restaurants in a multi-threaded environment. It stores the ratings in a map of restaurant ID versus rating. It doesn't sort the restaurant IDs. Instead, it keeps the list of restaurants with same rating together in a hash set. Now the total number of average ratings is 41. That is from 1.0, 1.1, 1.2 until 4.9, 5.0. It uses the data structure rating divisions, which is a hash map of average rating versus set of restaurants which have the same rating. So the restaurant IDs with rating 5.0 will all be then in the same set, and then the restaurant IDs with average rating 4.9 will all be in the same set, and so on. For updating rating, you need to initialize rating for that restaurant ID if it is not already initialized. Then you remove the restaurant ID from older rating division if it existed. Rating division's map is already initialized in the constructor itself. Next, what you do is you add the new customer rating to the restaurant's overall rating, and then you add the restaurant ID to the set against that new average rating. This is what we are doing in this line, to-do.add a restaurant ID. All these operations have a time complexity of order of 1. Hence, the overall time complexity for the update method is order of 1, which is pretty efficient. For fetching top n restaurants, we start from the rating division of 5.0, move on to 4.9, 4.8, and so on until we have either top n restaurants in our list or we have reached the rating division 1.0. Now, in each rating division, we sort all the list of restaurant IDs. We do this because our sorting strategy dictates that the restaurants with same average rating will be sorted lexicographically by their restaurant IDs. So finally, this is how we build the overall restaurants list. Coming back to our algorithm classes, class most rated restaurants returns list of top restaurants sorted by their average rating. It uses the class sorted set with lock to maintain a sorted list of restaurant IDs and update their ratings. The method set.getRestaurants is used to fetch top restaurants list, and the method set.update is used to update overall average rating of an restaurant. The other algorithm class most rated restaurants by food also uses class sorted set with lock. It needs to maintain a sorted list of restaurant IDs for each food item. So it actually uses a map of food item ID versus sorted set with lock to maintain the list of sorted list of restaurant IDs for each food item. So this is the only main difference here. Rest all methods is same, almost similar. Here it just fetches the corresponding sorted set with lock object for the given food item ID and updates the rating. And again for fetching, it fetches the corresponding sorted set with lock objects and use the method get restaurants in it to fetch the top n restaurants. Finally, to summarize, we have our entity class food item and food manager. Then we have class restaurant manager, which primarily returns list of all restaurants and list of all restaurants which sell a particular food item. Then we have our class order and orders manager, which take care of customer orders and rating an order. Also, when an order is rated, orders manager acts as a subject in the observer design pattern and notifies all the observers. Class most rated restaurants and class most rated restaurants by food are our observers. They observe the orders being rated and maintain data structures to build list of top n restaurants. Both are our search algorithm classes and they are both used from the class restaurant search manager. Both these classes use the class sorted_set with lock, which is a thread-safe data structure to maintain a list of top-rated restaurants in a multi-threaded environment based on their rating. And this class uses the class rating to manage the overall rating of restaurants. This was our overall solution. Now let's test it on CodeZym. This is question number 5 on CodeZym. Let's open it. Now let's copy our code and paste it here. Control C, Control V, and let's paste it, Control V here, and hit the run button. So actually I wanted to show you one thing. Yes, this is what. Basically it's giving compiler error, duplicate interface definition for Q05 restaurant rating interface. So what is happening is the code which is at the bottom, this class helper and the interface Q05 restaurant rating interface, we have to comment them back. They were commented when we copied the code, and I uncommented them so that I can get autocomplete in my local IDE IntelliJ. So let's comment them back and run it again. This time it should compile and pass all the sample test cases. So as you can see, it compiled successfully and it also passed the one sample test case. So let's submit for all the test cases. So as actually this code takes 60 seconds to 2 minutes to run, and as it compiles and tests run, this figure will get updated time and again. Our code has passed all the test cases and it took 50 seconds. Seeing your code pass all the test cases gives you the confidence that if you get the same or similar question in an interview, or even based on the same design patterns, then you will be able to do well on that as well. And I will put all this code in a blog and put the link to the blog in description as well as in comments. And I wish you the best of luck in your job interview preparation and wish you success in getting an amazing job offer with a great salary hike. Thanks for watching.